Welcome on board the A340, the perfect long-range aircraft for long, thin routes. A new concept in air travel designed to make the maximum efficient use of the air transport system and to take the world's airlines profitably well into the 21st century. Airbus industry has started to produce wide-bodies, A300 and A310, using conventional flight controls. Airbus has introduced with the A320 the latest concept of fly-by-wire technology, and this new family is now augmented by the A340 and the A330. The A340 and the twin-engined A330 benefit from a common production line, commonality in systems, and common new designed wing. An advanced aerodynamic wing structure, including integrated electronic flight controls, improving flight efficiency. The four-engined wide-body is offered in two sizes. The larger A340-300 has seat mile costs on a level with those of the largest four-engined airliners, while the smaller A340-200 has the longest range. A combi version is also available. Traditional servicing time will not exceed 30 minutes. The A340 can carry any standard unit load device using standard ground equipment in both forward and aft holds. The A340's spacious cabin offers genuine wide-body comfort. Large overhead stowages with integrated handrails. New generation audio-visual entertainment. Teletext telephone facsimile. Facilities for handicapped passengers. Alternative galley locations. Digital cabin intercommunication data system for ease of operation. Dedicated crew rest areas. The A340s can carry 262 or 295 passengers in basic versions, and up to 375 at the highest density. The cockpit design combines high technology developed for the A320, A321 with the wide experience gained from the A300 and A310 aircraft, currently in worldwide service. The A340 uses the two-man crew concept. 6 display units are interchangeable, switchable, and integrated into the same system architecture. Both captain and first officer panels incorporate a primary flight display which groups the main flight instruments such as airspeed, attitude, all in one. A navigation display gives the aircraft position on a graphic representation of the flight plan. These displays are the main components of the electronic flight instrument system. And the main central panel incorporates the 2 last display units, corresponding to the aircraft status. The upper engine warning display unit shows the aircraft parameters. Below, the system display unit shows the system diagrams and status. These 2 displays are part of the Electronic Centralized Aircraft Monitoring, or ECAM. The overhead panel push-button philosophy is identical to all Airbus aircraft lights-out philosophy. All's dark, all's right. The most frequently used functions are at the front. This forward zone is dedicated to system controls. The center row for engine-related systems arranged in a logical way. The aft zone is mainly for small maintenance panels. It has to be noted that all circuit breakers and most computers are installed in the avionics compartment under the cockpit. The crew pilots the aircraft with user-friendly side sticks. Engines are normally operated from the center pedestal panel. Master switches, thrust levers. The A340 is powered by 4 advanced CFM56 5C series engines. Versions of the CFM56 also power the A320 and A321. These have a high power-weight ratio and are FADEC controlled with low fuel burn and low emissions. Full Authority Digital Engine Control is a fully redundant engine control unit and an interface unit in relation with the aircraft systems. Let's have a look at some of these systems. The electrical power generation comprises 4 engine-driven AC generators, 1 emergency generator, 1 APU AC generator, 2 ground connectors. The DC network is supplied via 4 transformer rectifiers or 3 batteries, 2 of them being able to supply the AC system via a static inverter. 1 transformer rectifier and 1 battery are dedicated to the APU. Hydraulic power is provided by 3 independent systems, green, blue and yellow, managed by a monitoring unit. Priority supplies for flight controls and brakes. A ram air turbine may be automatically deployed to pressurize the green system. All flight control surfaces are hydraulically powered and electrically controlled. Due to the use of fly-by-wire technology, the A340 is protected against abnormal flight conditions. Primary and secondary computers receive orders from side sticks, conventional rudder pedals, and pedestal-mounted levers for speed brake. The landing gear comprises 2 main landing gear assemblies. A centerline gear and a nose landing gear. High-pressure air is supplied from different stages of the engine compressor, the APU compressor, or 2 ground connectors. The air conditioning system provides temperature-controlled air for each of the 4 zones: cockpit, forward, mid and aft zone. Fuel is stored in 6 tanks, an outer and an inner tank in each wing, a center tank in the center fuselage area, and a trim tank in the horizontal stabilizer. The fuel system delivers fuel to the engines and APU. Fuel control and monitoring computers manage fuel transfers to optimize the aircraft center of gravity position, so reducing the aircraft drag. A pilot interactive system, the auto flight system, gives orders to the flight controls and to the engines. It calculates the position of the aircraft and defines the flight plan. The AFS consists of 2 flight management, guidance and envelope computers, or FMGEC. A flight management part is for navigation, performance optimization, and navigation aids tuning. A flight guidance part is for autopilot commands, flight director and thrust commands. The Flight Control Unit, or FCU, on the central glare shield provides the short-term interfaces between the crew and the FMGS. 3 multipurpose control and display units, or MCDUs, provide the long-term command interfaces. The central maintenance system provides maintenance personnel with a central means to display, interrogate and test the status of various aircraft systems through one MCDU. Levels of maintenance are easily identified for line stop or hangar operations, such as line replaceable unit removal or troubleshooting. The CMS has the ability to display the failure messages in plain English, interrogate the byte of the various systems, initiate systems tests via the MCDU. CMS increases efficiency, improves dispatch reliability, and reduces maintenance costs. An optional aircraft condition monitoring system, ACMS, provides additional functions on aircraft performances, engines, and APU monitoring. And also reports can be sent in advance to the base through the ACARS, Aircraft Communication, Addressing and Reporting System. Airbus has been pleased to welcome you on board, and we hope to see you again soon on one of our next family members.